the 5.7 notes. Today we're going to be talking about how to combine two functions together to create a new function using 4 operations: sum and difference, product, quotient, and a new one called composition. Composition you've probably never done before, so pay extra special attention to that one. When we are doing sum and difference, I'm not going to overcomplicate this. Sum means to add together. Difference means to subtract. All you are pretty much doing is combining like terms. And then my only suggestion to you is if there is a minus, you want to distribute the minus first. I will do that in part B. One of the things about this section is that in the directions, it's going to tell you what f of x and g of x are. So right up here. So f of x is x plus 3, and g of x is x squared minus 9. So when it asks us to do f of x plus g of x, that just means you're adding them together. So I'm going to copy down f of x, and then below that, I'm going to copy down g of x. Being really careful to make sure I'm lining up like terms so that I don't end up adding two things together that I'm not allowed to add together. And then you just simply combine those like terms, which in this case is really just 3 minus 9. That's the only thing you're actually allowed to add together. And that gives you -6. The x squared and the x stay out front, and there you go. The next one is pretty much the same thing, but it is f minus g of x. So what I'm going to do is I'm going to go ahead and write f of x right here. Then instead of writing g of x underneath, I'm going to go ahead and multiply g of x times the negative that's right here. And that's what I'm going to write underneath. So if I go ahead and distribute that negative, it's going to be negative x squared, and then negative times -9 is positive 9. So that way I don't have to worry about the fact that I'm subtracting 3 minus -9, because all those negatives just sound really confusing. And then all I have to do is add like terms together again. So I never really actually subtract. I multiply by -1 and then just add them together. The second operation is technically product. That means you're going to multiply. Basically, you just have to still make sure that you're doing what we've always done, and that is you're going to have to distribute, or some of you still call it FOIL, and that's fine. So, for example, f times g means you're going to take f of x, which is x plus 3, times g of x, which is x squared minus 9. And then I'm going to take both of these times x squared like this. X times x squared is x cubed. 3 times x squared is 3x squared. And then I'm going to multiply both of them by -9. So x times -9 is -9x. And 3 times -9 is -27. Now, you might have done yours in a slightly different order to me, and that's fine. There really is nothing to combine here now because they all have a different power. So it's just simply x cubed plus 3x squared minus 9x. Oops, not plus 27, but minus 27. There we go. And that's it. So none of that's really new. We've done all of that before. The third one's not really very new either. Quotient means to divide. This usually means that it's going to turn into a fraction. We do want to try and simplify this fraction. In order to simplify, you are going to simplify by factoring. I know some of you really missed factoring. You just were begging for it to come back. No, seriously though, some people were because they really like it, and some of us absolutely hate it. So pay attention to the order here. F goes first, so F goes on top of the fraction, which f of x is again x plus 3, and g of x is x squared minus 9. So that goes on the bottom. Then I can factor that. It's a difference of squares because these are both perfect squares and they're being subtracted. So the square root of 9 is 3, meaning that this would be x plus 3, x minus 3. And that's kind of replacing it down there with the factored version. Then you'll notice that you have an x plus 3 on the top and the bottom. So we get to cross those out. And that basically leaves the x plus 3, but you'll notice that it's on the bottom. So it's actually 1 over x minus 3. Like that. Now on to the newest one, composition. To compose something means to make it up using pieces. So essentially what this is going to be is f of g means to plug g into f. And g of f means to plug f into g. And by plug, I really mean substitute. Whatever makes it more sense to you. It can also be written instead of f of g with this o in the middle, which notice that that is different than the multiplication symbol. You could also just write f g of x like this, or g f of x like this. They are exactly the same thing. So for part E, we're going to take g of x and plug it in to f. So if f of x is x plus 3, then g of f of x is where we replace the x part of this equation, or this expression, with x squared minus 9. But then we still keep that plus 3 that was already outside the parentheses. And then pretty much your only job is to look and see, oh, I can add those together because they're like terms. So that'd be x squared minus 6. And that's really it, guys. It's just simple substitution, but it does sound really weird at first. G of f of x is where you're going to take f, plug it into g. So you start with the structure of f of x, which is x squared, or g of x, which is x squared minus 9, and then you substitute x with x plus 3, because that's what f is. So you're starting with g of x and replacing the x with f of x. And then you just have to FOIL this out, because x plus 3 squared is x plus 3 times x plus 3, which is x squared plus 3x plus 3x plus 9. And then you keep that minus 9 at the end, and you're going to combine like terms. 3x plus 3x is 6x, and 9 minus 9 is 0, so you don't have to write it at all. And then the x squared didn't have any like terms, so it just stays in front. And those are your 4 operations. What we're going to do down below is just practice. So each problem on your assignment is going to kind of give you the f of x and the g of x up here. So make sure you're paying attention to the directions. Then for part A, it just wants you to add them together, f plus g. So I'm simply going to write f of x squared plus 4x minus 5. And underneath, I'm going to write g of x, which is x minus 1. And I'm simply going to add together my like terms. So the x squared stays the same. 4x plus 1x is 5x. And negative 5 minus 1 is negative 6. Part B is almost exactly the same thing, but you'll notice that there is actually a minus sign right here in the middle. Sorry, I covered it up. So I'm going to keep f of x the same. But this time, before I write g of x underneath, I'm going to multiply it by negative 1 because of that minus right there. So instead of adding x minus 1, I'm actually going to be adding negative x and positive 1. So the signs just flip, and that's about it. Which means the x squared stays the same, but 4x minus 1x is 3x, and negative 5 plus 1 is negative 4. So they're really similar problems. And then something new about part C is it actually tells you that x is 3. What that means is I'm going to find f of 3 and g of 3 and just subtract them. So I'm going to plug 3 in for f of x and 3 in for g of x, which is going to be, instead of x squared plus 4x minus 5, it's going to be 3 squared plus 4 times 3 minus 5. There we go. And then it'll be 3 minus 1 for g of x. And I'm going to solve both of these and then just subtract them. So 3 squared is 9, 4 times 3 is 12, and then there's a minus 5 at the end. 9 plus 12 is 21. 21 minus 5 is 16. And then over here on the other side, 3 minus 1 is 2. And then you just have to make sure that you do the right operation in between. And this one was telling us to subtract them. So 16 minus 2 is 14. And again, I'm subtracting because that's what it told me to do right here. So you find your two answers and then just subtract. Or add or multiply if that's what it tells you to do. For instance, D, we're going to find f of 2 and g of 2. And whatever those two numbers are, we just multiply them together. So f of 2, 2 squared, plus 4 times 2 minus 5. I'm just using the function and replacing x with 2, which means g of 2 is just 2 minus 1. And then I solve. 2 squared is 4, 4 times 2 is 8, and then 4 plus 8 is 12, 12 minus 5 is 7, times 2 minus 1, which is 1, and 7 times 1 is 7. Now, E goes back to not telling us what x is, so it's going to be more of an expression like A and B. If it tells us what number x is, like C and D, you'll get a number answer. E is division, so I'm going to write f of x on top and g of x on the bottom. And then remember, we're going to simplify by factoring. So I need two numbers that multiply to negative 5 and add to 4, which is 5 and negative 1. So x plus 5, x minus 1, over x minus 1. And that x minus 1 is on the top and the bottom, so it cancels. And my answer is just x plus 5. Then f is g of f of x, meaning you're going to take f of x and plug it into g. So you have to start with g of x, and then you replace the x with f of x, which is x squared plus 4x minus 5. And then that minus 1 just kind of stays out there for now. Then that parentheses is not getting multiplied by anything or squared or anything, so you just add together your like terms right here, and that's pretty much it. The x squared and the 4x stay the same, but then you go ahead and add negative 5 and negative 1, which makes negative 6. Voila. Now, G is just asking us for the same thing but backwards. And now is kind of my chance to tell you that sometimes it gets a bit tricky. So you're taking G and plugging it into f of x. So instead of x squared plus 4x minus 5, you replace both of those x's with g of x, which is x minus 1. Like that. But then the x minus 1 squared means you have to do x minus 1 times x minus 1. So x squared minus 1x minus 1x plus 1. And then you take that 4 and multiply it by x, which is 4x. And 4 times negative 1 is negative 4. And then the negative 5 stays. So essentially this one just takes a while to simplify. They're all skills you can do. It's just a little bit annoying. I'm going to go ahead and add my x's together. I've got negative 1x, and 4x. Negative 1 plus negative 1 plus 4 is 2x. And then I'm also going to go ahead and add together my constants. 1, negative 4, and negative 5. 1 minus 4 is negative 3, and negative 3 minus 5 is negative 8. And then you're going to keep that x squared in front. It didn't have anything to add to, so it just stays the same. And there you go. H is kind of nice because it is still doing a composition. That's what that open circle means. But this time I'm going to go ahead and find g of 4. G is x minus 1, so g of 4 would just be 4 minus 1, which is 3. Then I go ahead and find f of 3. So whatever answer you get to the inside one, you plug that answer into the outside one. And since f of g, or g of 4 is 3, now you're just finding f of 3, which is 3 squared minus 4 times 3, plus 4 times 3 minus 5. Or 9 plus 12 minus 5. This should sound familiar because we actually did it right here earlier. It's 16 is my answer. And there you have it. Alright, very last problem wants us to write an equation for a and b so that a of b of x equals square root of 8x minus 4 plus 11. So b is the one that we're plugging into a. And one thing I'm going to kind of point out on this one, on part F, is see how like it kind of got put in the parentheses? That was g of x because it's the plug-in part. So since b is the plug-in part of my next one, that is going to be b right there, 8x minus 4. And if this is the thing that I'm plugging into, that's what would have just been an x for a of x. So if I replace that part back with just x again, a of x is the square root of x plus 11. It's kind of like trying to pick out the outside and inside pieces instead of just plugging them into each other. You're kind of trying to reverse that and take it apart instead of put it together.